This will be a multi-part video about the one derivation of the sum rules for sine and cosine. This is a modification of something that I often do as a directed exploration, but I'm going to lead you through it, but hopefully there's some times when you could pause the video and do a little bit for yourself. So the goal here is to derive the sum rules for sine and cosine really from a more fundamental fact, and that's about how does rotation work. There's some really beautiful formulas for rotating a point in the plane by a certain angle, and it's not really any more work to get those than to get the sum rules in this setup. And so we're going to get those, and the sum rules will fall out. So here's the setup. I'll show you a picture, and we'll go back and forth between the text and the picture. We're going to start with a point x and y. It could really be anywhere in the plane, but just for a little bit of convenience, we will put it on the unit circle. Just makes things a little simpler, but it really, nothing is super special to a unit circle here. We're going to rotate it by an angle theta, counterclockwise meaning positive, of course, and call the resulting point x prime, y prime. And then we want to find formulas for the coordinates of the new point in terms of the coordinates of the old point and how much we rotate it by. Really a very natural thing to do, so let me show you the picture. There's a lot of stuff in this picture, but right now, just take a look at xy. That's the point we're starting with. Happens to be on a circle just for convenience, and so we can relate it nicely to cosines and sines without too much complexity. And then theta, the sketchpad, it was a little hard to actually put in the theta in the right place here, but just a text for it. But there's various ways to think about theta. And so theta is really controlled by the blue dot here. And so, for example, if theta is 90 degrees, that's the amount of rotation. So the main reason we're interested in theta is we're taking xy and we are rotating it by 90 degrees to get x prime, y prime. So notice the angle between the direction to xy and the direction x prime, y prime, in this case, that's 90 degrees. As I move the blue dot over, that gets bigger or smaller. And so hopefully you can see as I move it, the blue dot is definitely controlling the amount of rotation. But the reason I put the blue dot right here is that I want to remember that anytime I have an angle like theta, even though I'm thinking of it as an amount of rotation, I could locate it in standard position. So for example, 90 degrees, if I put it in the standard position, it's right here. If it's like 120 degrees-ish, then it's going to be over here. And another reason for that is very soon we're going to see that not only do we want to rotate x and y, but to get these coordinates in geometrically, what we always do is we draw this triangle. This should be a very familiar triangle of dropping an altitude of the x-axis. Then the x-coordinate of the input point is this leg, and the y-coordinate is this leg. And notice that since this guy starts at angle 0, this x leg, and if I rotate the whole triangle, you can see I'm rotating the whole triangle all at once. If I rotate that by 120 degrees, then in fact this leg shows up right at 120 degrees because it didn't start out with any weird angle. So that's how to read this sketch, that the blue dot controls the rotation, and you are interested both in how much xy rotated to the target point, that's our main goal, but it's also kind of nice that the blue dot also shows you exactly how far this point at the base of the altitude there has rotated. So we'll come back to that. So let's see what the goal is and what the plan is. So the key will be we're going to relate x prime and y prime. We're going to kind of break it up into pieces. We're going to relate it into four quantities a, b, c, and d, shown in the sketch. I'll go back to it in a second. And we got to be careful with the signs of these guys because they're directed distances. That will be crucial to get the formula correct. We're going to focus on the situation just to be kind of definite about the picture when xy starts in Q1, the quadrant 1, and x prime, y prime ends up in quadrant 2. But let me assure you there's nothing special about this. It's a very, very general formula, but it's nice to be definite when you're just trying to get some intuition. So that's the picture. xy starts out in Q1 and x prime, y prime, we're going to try and choose theta so it sort of ends up in Q2, mainly just to keep these triangles well separated from each other so you don't confuse the two. So what do I mean by A, B, C, and D? The key is really this point right here. Like I said, we're going to rotate the entire triangle, this entire triangle that helps us understand how x and y make up this point, and the foot of this point gets rotated over to here. And what we're really going to do is we're going to get to x prime, y prime by starting at the origin, first going to, I always do that, first going to this intermediate point, which will be simpler to analyze. Why? because it came from a point on the x-axis. That's a particularly simple place to start. Okay, and then from there we'll figure out how much we have to move to get to x prime, y prime. So A is going to be the x-coordinate of this intermediate point, and C is going to be its y-coordinate. And then B is going to be how much you have to move from this guy, should give it a name, sorry, over to x prime, y prime. And D is going to be how much you have to move from this guy and how much you have to move vertically from here to here. Combining all that, I claim we'll get x prime, y prime. So that's a key part of the strategy. Okay, so we're going to just jump right into that and find A, B, and C. We'll focus on A and C first because those relate to x and theta. And then we'll find B and D. We'll combine those in a very simple way. And then that'll be enough to get our first big formula. Then we will go back to the sketch and bring in the angle phi and think about how you would describe rotation in terms of angles. But that's all going to be a nice downhill slide because everything after that's going to be easy once we get the A, B, C, and D and combine them. So that's the plan, and the next video will start to implement that plan.